There are billions of Earth-like planets out there in the Milky Way galaxy just waiting to be discovered by us. So in today's video, we will be talking about one such planet that might be suitable for human habitation. Welcome to our channel. Don't forget to subscribe to our channel to never miss an update on the latest space discovery. Let's start. Gliese 667cc, also known as GJ 667cc, HR 6426cc, or HD 1563844cc, is an exoplanet orbiting within the habitable zone of the red dwarf star Gliese 667c, which is a member of the Gliese 667 triple star system located in the constellation of Scorpius. The planet was found by using the radial velocity method from radial velocity measurements via observation of Doppler shifts in the spectrum of the planet's parent star. Mass, radius, and temperature. Gliese 667cc is a super-Earth, an exoplanet with a mass and radius greater than that of Earth, but smaller than that of the giant planets Uranus and Neptune. Its minimum mass is about 3.7 Earth masses. Like all planets in this system, Gliese 667cc orbits very close to its host star. As a result, it is tidally locked, meaning that one side of the planet always faces towards the star, while the other side remains in darkness. In addition, since the planet is so close to its host star, it experiences extremely high atmospheric pressure, and temperatures on the sun-facing side can reach 200 to 400 degrees Celsius. However, on the dark side of the planet, temperatures plummet to lows of minus 180 degrees Celsius. On average, the equilibrium temperature of Gliese 667cc is estimated to be 277.4 Kelvin or 4.3 degrees Celsius. Its expected radius is around 1.5 r, dependent upon its composition. Due to the limited range of radii that current detection methods can confidently distinguish, Gliese 667cc is assumed to be either entirely rocky or entirely liquid. However, future observations may reveal a more accurate value. Host star. The planet orbits a red dwarf or M-type star named Gliese 667c, orbited by a total of 2 planets. The star is part of a trinary star system with Gliese 667a and b both being more massive than the smaller companion. Gliese 667c has a mass of 0.31 m and a radius of 0.42 r. Its temperature is 3700 K, but its age is poorly constrained. Estimates place it greater than 2 billion years old. In comparison, the Sun is 4.6 billion years old and has a surface temperature of 5778 K. This star is radiating only 1.4% of the Sun's luminosity from its outer atmosphere. It is known to have a system of 2 planets. Claims have been made for up to 7, but these may be in error due to failure to account for correlated noise in the radial velocity data. Since red dwarfs emit little ultraviolet light, the planets likely receive minimal amounts of ultraviolet radiation. Gliese 667cc is the second confirmed planet out from Gliese 667c, orbiting towards the inner edge of the habitable zone. From its surface, the star would have an angular diameter of 1.24 degrees and would appear to be 2.3 times the visual diameter of our Sun as it appears from the surface of the Earth. Gliese 667c would have a visual area 5.4 times greater than that of the Sun, but would still only occupy 0.003% of Gliese 667cc's skysphere, or 0.006% of the visible sky when directly overhead. Orbit. The orbit of Gliese 667cc has a semi-major axis of 0.1251 astronomical units, making its year 28.155 Earth days long. Based on its host star's bolometric luminosity, GJ 667cc would receive 90% of the light Earth dose. However, a good part of that electromagnetic radiation would be in the invisible infrared part of the spectrum, in the habitable zone. The question you must be having in your mind right now is, what is the habitable zone? The habitable zone, also called the Goldilocks zone, is the range of distances from a star where conditions are suitable for life as we know it to exist. Scientists believe that life as we know it requires liquid water, which is why the habitable zone is often referred to as the liquid water zone. It is named after the fairy tale character Goldilocks and the three bears. In the story, Goldilocks tests the chairs, beds, and tables in the house of a family of bears by sitting on them, lying on them, and walking on them to see if they are too hard or too soft. Similarly, the habitable zone is defined by the range of distances from a star that are not too hot and not too cold, but just right for life as we know it to exist. The habitable zone of a star system is not a fixed distance, but rather a range. The inner edge of the habitable zone is defined by the distance from a star where the temperature is too high for water to exist as a liquid. The outer edge of the habitable zone is defined by the distance from a star where the temperature is too low for water to exist as a liquid. The habitable zone of our solar system, for example, is between Venus and Mars, because the temperature on these planets is just right for water to exist as a liquid. However, it is important to note that the presence of liquid water is not enough to support life. Other factors, such as the atmosphere, chemical activity, and energy sources, also play an important role. For example, although Mars is within the habitable zone of our solar system, its atmosphere is too thin to support liquid water on the surface. Despite this, scientists believe that Mars may have had the conditions necessary for life to exist in the past. Similarly, Venus is within the habitable zone, but its thick atmosphere and high atmospheric pressure make it too hot for life as we know it to exist. As discussed earlier, Gliese 667cc orbits very close to its host star, Gliese 667c. Due to this proximity, it receives substantial heat from its host star, which makes it potentially habitable. But is it really habitable? If Gliese 667cc were to have a similar atmosphere to Earth, then the global average surface temperature could be around 277.4 K or 4.3 degrees Celsius. This temperature range is suitable for liquid water to exist on the planet's surface. In addition, Gliese 667c is a red dwarf star, which means that it emits most of its light in the infrared part of the electromagnetic spectrum. This could potentially allow for liquid water to exist on the planet's surface without being boiled away by intense radiation. However, it is important to note that red dwarf stars are also known to frequently flare and emit large bursts of radiation. These flares could potentially disrupt any liquid water on the planet's surface and make it uninhabitable. Also, Gliese 667cc is a tidally locked planet, which means that one side of the planet always faces towards the host star, while the other side remains in darkness. This could lead to extreme temperature differences between the two sides of the planet and make it inhospitable for life as we know it. Overall, while Gliese 667cc does receive enough light and heat from its host star to potentially support liquid water on its surface, further studies are needed to determine whether it is truly habitable or not. Factors such as the planet's atmosphere, magnetic field, and the frequency of stellar flares will need to be considered before we can say for sure whether life could exist on this distant world. Is there any life on Gliese 667cc? We simply don't know whether or not there is any life on Gliese 667cc. There has been no direct observation of the planet, and no signals from any potential civilizations have been detected. Some scientists estimate that the planet could potentially be habitable based on its size and distance from its star. However, others argue that the frequent stellar flares from the red dwarf star could make the planet's surface too hostile for life to thrive. Until we have more information about the planet's atmosphere, magnetic field, and other factors, it is impossible to say whether or not Gliese 667cc could support life. Could humans live on Gliese 667cc? At this time, it is not feasible for humans to live on Gliese 667cc. The planet is located 23.62 light-years away from Earth, and it would take a spacecraft over 20,000 years to travel the distance. Additionally, the planet's proximity to its host star and its tidal locking make it potentially unsuitable for human habitation. The side of the planet facing the star would be extremely hot, while the other side would be in permanent darkness. Furthermore, the frequency of stellar flares from the red dwarf star could pose a threat to human life on the planet's surface. Finally, there is no guarantee that the planet has an atmosphere or that it is rich in resources necessary for human survival. More research is needed to determine the planet's habitability before any plans for human colonization can be made. So would you like to live on such a planet? We would love to hear from you in the comments below. And don't forget to subscribe so you don't miss any new videos. Thanks for watching. We'll see you next time.